given three sets where set A containing an integers which satisfies x square minus 9 is equal to 0. That is x plus 3 into x minus 3 is equal to 0. So here x is equal to plus or minus 3. Therefore, we can write the set A is equal to minus 3 comma plus 3. And coming to the set B, it's containing a natural numbers which lies between 2 and 5, where 2 is included, 5 is excluded. So we can write the set B is equal to 2 is included, so we can write 2, then 3, and then 4, which is less than 5. So we can consider set B is equal to 2, 3, 4, and then set C x such that x is a prime number less than or equals to 4. Prime numbers less than or equals to 4 are 2 and 3. So we can write set C is equal to 2 comma 3. Now we need to find B minus C union A. So B minus C is equal to, that is 2 comma 3 comma 4 minus C is nothing but 2 comma 3. So from 2 3 4, if you remove 2 3, so we'll get 4. So B minus C is 4, and then B minus C union A is equal to 4 union A value is minus 3 comma plus 3. So we can write minus 3 plus 3 and 4. So which is our option 1. So minus 3 plus 3 comma 4. A and B are two sets such that number of elements in set A is equal to 3 and number of elements in set B is equal to 6. And we need to consider the statements, the minimum number of elements in A union B and maximum number of elements in A intersection B. For minimum number or maximum number, so minimum or maximum number of elements in A intersection B or A union B, we need to consider the two cases. One is subset, one set is subset to another set, since the number of elements in A is smaller than number of elements in B, so A must be subset to B. So A is subset to B, or we can consider one more, A intersection B is empty, means both are disjoint sets. These are the two cases we need to consider. To get the minimum number of elements in A union B, so we have to consider the case A is subset to B, because for maximum for A union B, minimum will be here in this case and maximum will be in the case of disjoint. And for A intersection B, so minimum will be here in A intersection B and maximum will be in A subset to B. So we need to consider this case. So therefore the statement 1, so minimum number of elements, that is minimum n of A union B is equal to, when A is subset to B, so we can write A union B is equal to B, that is number of elements in B, which is equal to 6. So this must be the minimum number of elements in A union B, but here it is given 3, which is wrong. So statement 1 is wrong. And coming to the second statement, maximum number of elements in A intersection B means in the first case. So here A intersection B can be considered to be A because A is subset to B. So which is equal to number of elements in A, that is 3. So maximum number of elements in A intersection B is 3, which is the right answer. So statement 2 is correct. So statement 1 is wrong and statement 2 is false, which is our option 2. domain of the function f of x is equal to 1 upon under root of x minus 2 into x minus 5, and this function is defined only when the denominator x minus 2 into x minus 5 under the root should be positive, because whenever the function 1 upon under root of g of x, this function to be defined where g of x must be greater than 0. So here x minus 2 into x minus 5 is greater than 0, and we also know that x minus a into x minus b is greater than 0 for a is smaller than b. We can consider the solution should be below a and above b, that is x is less than a or x is greater than b, that is minus infinity comma a union b to infinity. So here in this case, so x minus 2 and x minus 5, so we can consider 2 and 5, 2 is smaller than 5, and the region we can consider below 2 and above 5. So we can conclude the answer as x must belongs to minus infinity comma 2 union 5 to infinity. So which is our option 2. Given that f of x is equal to sine greatest integer of pi square of x minus sine of greatest integer of negative pi square of x. So here where the square brackets are indicating greatest integer function which is less than or equals to x. And we know that pi value is 3.14 approximately. So pi square value lies between 9 and 10. Therefore, the greatest integer of pi square will be taken as 9. The greatest integer which is less than or equals to pi square will be 9 here. And also minus pi square lies between negative 10 and negative 9, and here we can say that the greatest integer which is less than minus pi square will be minus 10. So we can write the greatest integer of negative pi square which is equal to minus 10. So the given function we can write f of x is equal to sine of 9x minus sine of, and here negative 10x, and we know that the sine of negative theta is equal to minus sine theta. So here sine 9x minus of minus plus sine 10x. This is f of x. Now if we see the options, suppose if I take the first option, if x is equal to 0, f of 0 is equal to sine 9 into 0 is sine 0 plus sine 10 into 0 is sine 0. Sine 0 value is 0, so 0 plus 0 is 0, which is true. And if we see the second option, at x is equal to pi by 2, f of pi by 2 is equal to sine 9 times pi by 2 plus sine 10 times pi by 2. So 9 times pi by 2 we can write it as 4 pi plus pi by 2, and this is sine 5 pi. Sine n pi is always equal to 0 for any integer. So this value will be 0, sine 5 pi, and this is sine 4 pi plus pi by 2 can be taken as sine pi by 2. Sin pi by 2 value is 1. So we can write 1 plus 0, which is equal to 1. So second option is also true. And coming to the third option, x is equal to pi by 4. F of pi by 4 is equal to sin 9 times pi by 4 plus sin time 10 times pi by 4, which is equal to sin 9 pi by 4, we can write it as sin 2 pi plus pi by 4, and here it is a 5 pi by 2. So we can write 2 pi plus pi by 2, which is equal to 2 pi plus theta is sin theta. So we can here sin pi by 4, 1 by root 2, and here sin pi by 2 is 1. So 1 plus 1 by root 2, this is also true. So option C also true. And coming to the fourth option, f of pi, when x is equal to pi, f of pi is equal to sin 9 pi plus sin 10 pi. For any integral multiple of pi, sin value is equal to 0. So we can write this is 0 plus 0, which is equal to 0, but given it is minus 1. So this is false, not correct. So therefore we can say that option D, which of the following is not true? Option 4 is the answer. Which of the following is not correct? First option, cos 5 pi is equal to cos 4 pi. If you can see in the unit circle diagram, whose x coordinates can be taken as cos theta and y coordinate can be taken as sin theta. The radius is 1 unit. 0 comma 0 is the center. So here we can consider cos theta. Here 1 comma 0 and here minus 1 comma 0, which indicates that cos for every even multiple of pi, that is cos 2n pi, will be equal to plus 1. And here we can say cos odd multiples of pi, that is 2n minus 1 of pi, or 2n plus 1 of pi, is equal to negative 1. So cos 5 pi is an odd multiple of pi, so we can say this is minus 1, and cos 4 pi, it is an even multiple of pi, which is plus 1. So minus 1 plus 1 both are not equal, so we can say that option 1 is this is not correct. At the same time, if we can see second option for confirmation, sin 2 pi, and here the sin y coordinate, sin for any multiple of like either even multiple 2 pi or 4 pi, or any multiple, sin n pi is always equal to 0. So here sin 2 pi is 0, sin 2 pi is equal to sin of negative theta is minus sin 2 pi, but sin 2 pi value is 0 and here negative 0. So 0 is neither positive nor negative, so we can say this is 0, which is true. This is correct. And coming to the third option, sin 4 pi is equal to sine 6 pi. So any multiple of pi, sine value is 0. So 0 is equal to 0. So this is also true. And last fourth option, tan 45 tan of negative 315. We know that tan of negative theta is equal to minus tan theta. So we can write minus tan 315 degrees, and 315 we can write it as 360 minus 45. And also tan 360 minus theta is in the fourth quadrant negative. So minus of minus tan 45 degrees, which is equal to tan 45 degrees. So tan 45 both are same here, that is 1 is equal to 1. This is also correct. So which is not correct is only the first option. So we can go with that. Given that cos x plus cos square x is equal to 1, which implies cos x is equal to 1 minus cos square x. That is cos x is equal to sin square x. At squaring on both sides, cos x whole square is equal to sin square x whole square. That is cos square x is equal to sin power 4x. So here we can write sin square x is equal to cos x, and sin power 4x is equal to cos square x. So adding both, sin square x plus sin power 4x is equal to cos x plus cos square x. So according to the question, cos x plus cos square x is 1. And hence we can say sin square x plus sin power 4x value is 1, which is option 2. Given the observations xi 4, 7, 8, 9, 10, 12, 13 and 17. And here we can say that number of observations n is equal to 8. Let's find the mean of the data. So mean is equal to sum of the observations by number of observations. So we can write 4 plus 7 plus 8 plus 9 plus 10 plus 12 plus 13 plus 17 divided by 8. So if you find the sum, you will be getting 80 divided by 8, which is equal to 10. So therefore, mean x bar is equal to 10. And we know that the mean deviation about the mean, we have summation mod of xi minus x bar divided by the number. So here x bar is 10 and each observation is 4. So let us find the differences, which is equal to 4 minus 10 plus 7 minus 10 plus 8 minus 10 plus 9 minus 10 plus 10 minus 10 plus 12 minus 10 plus 13 minus 10 and then 17 minus 10. The whole divided by number of observations is 8. So which is equal to 4 minus 10 is negative 6. So mod is there. So we can write 6. And 7 minus 10 is negative 3. We can take the mod. So plus 3. So all observations will be, the differences will be positive only. So let me write 8 minus 10. We can say 2. And 9 minus 10 which is 1. 10 minus 10 0. And 12 minus 10 is 2. And 13 minus 10 is 3. And 17 minus 10 is 7. Divided by 8. This is 1 upon 8 times. And here I can say the sum is 24. So 24 upon 8 is 3. So we can say that the mean deviation about the mean of the given data is 3, which is our option 2. Given for a random experiment, it has 5 outcomes W1, W2, W3, W4 and W5, and the probabilities are W1 outcome is given as 1 by 6 and W2 outcome is given A, and W3 outcome we need to find, which is, let us consider to be X, and W4 outcome which is B, and probability of the W5 outcome which is 1 by 12. And we know that the sum of the probabilities is, that is summation P of Wi, where I is equal to 1 to 5, which is equal to 1. That is P of W1 plus P of W2 plus P of W3, P of W4 outcome, and probability of fifth outcome, which is equal to 1. So here we can write 1 by 6 plus A plus X plus B plus 1 by 12 is equal to 1. Or here we can take the LCM is 12, 1 by 12. So here 2 plus A plus so 2 plus, and here we can write 12A, and here 12B, and here we can write 1, which is minus 1, is equal to negative X, or simplifying, so 1 by 12 times of 3 plus 12A plus 12B minus 1 is equal to negative X, and it is also given for us 12A plus 12B minus 1 is equal to 0. That is 12A plus 12B is equal to plus 1. So 1 by 12 into 3 plus 1 minus 1 is equal to negative X. So we can say 3 plus 1 4, 4 upon 12 minus 1 is equal to negative X, or we can write X is equal to 1 minus 4 by 12. So 12 minus 4 is 8 by 12, that is 2 divided by 3. So therefore the value of X is 2 by 3, which is our option 1. Given that a 6-face die having 2 faces each with number 1, so we can say the probability of getting 1 is 2 out of 6, because total 6 faces are there, of which 2 faces are with number 1 and 3 faces each with number 2. So probability of 2 is out of 6, 3 faces are there. So 3 out of 6 and 1 face with the number 3. So we have 1 out of 6. So total 2 plus 3 plus 1, 5, 6. 6 faces are covered. And we need to find probability of 1 or 3. Since these events are independent, so we can write P of A union B. If A and B are independent, P of A union B is equal to P of A plus P of B. So where P of A intersection B will be equal to 0. So here we can write P of 1 or 3 is equal to P of 1 plus P of 3. P of 1 is 2 by 6 and P of 3 is 1 by 6, which is 3 of 6, which is equal to 1 by 2. So we can go with an option 2. Given on a set A is equal to A comma B comma C, we need to find the number of equivalence relations which are containing B comma C one ordered pair. Equivalence relation it should be reflexive, that is, for every A belongs to capital A comma A must belongs to the relation R, and it should be symmetric, that is, if A comma B belongs to R, which implies B comma A must belongs to the relation R. And coming to transitive, if A comma B belongs to R and B comma C belongs to R, then A comma C must belongs to R. So a relation which satisfies all these three conditions said to be equivalence. So let us write, say R1 is equal to, first it should be reflexive, so we can write A comma A, B comma B, C comma C. For every element it should be satisfying. And now along with that, B comma C is to be included, so I can write B comma C. And now to make this condition, symmetric condition to satisfy, if B comma C belongs to R, then C comma B must belongs to R. So I must write C comma B. And now B comma C, C comma B and B comma B. So we can write this is one of the possibility equivalence. It is also transitive. And let us try another one. R2 is equal to, again we'll write the same A comma A, B comma B and C comma C, and also to be included B comma C. If B comma C is included, then C comma B should be included. Along with this, we can consider one more ordered pair we can try. Let us consider A comma B to be taken. If A comma B is taken, then for symmetric condition, B comma A must be there. So we must write, we must take B comma A, and also for transitive, if we can consider this A comma B and B comma C, then there must be A comma C. A is related to B and B is related to C, then A must be related to C. So we must consider A comma C to make this relation transitive. Now if A comma C is existing, then for symmetric, C comma A must be there. So if you take one element, one extra element, that is A comma B, so we need to consider B comma A and then A comma C and then again C comma A. So almost all the ordered pairs are there, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is A cross A. So this is the maximum possibility of getting. So only these are the two relations where we can find equivalence. So the number of equivalence relations are only 2, which is option 3.